So basically, different sources will have also different types of water quality, and we have a lot of sources of water from groundwater, surface water, stormwater. We have also wastewater, brackish water, seawater, and even treated wastewater will have a different quality compared to the raw wastewater. So all of these water bodies here will differ definitely on some aspects, and some water quality parameters are quite related to a specific source of water. So sometimes if we are given a water quality, then we will be able to know exactly where the water is coming from. So for example, if we compare groundwater versus surface water, basically, as we all know, the groundwater are those water that are located beneath the earth. So when you say like that, these water are confined under the grounds. So looking at this type of water, so it means there will be a lot of soil on top of the water table, and the soil usually below the crust, around 762 meters, are those usable fresh water, and it sieves and penetrate in soil pore spaces and the fractures of rock formations as well. And it is the largest single supply of fresh water available for use by human beings. And if you look and differentiate this one with groundwater, you will find out that the quality of the groundwater versus the surface water is most stable because they are underneath the ground. They are not exposed to the surface, and so they have more stable quality there. But also they will be having more minerals there because of the dissolution of of rocks into minerals and dissolve into water as well. So we'll be able to differentiate these two in the next slide. On the other hand, surface water is those water that are available and exposed to the surface. Main examples are river and lakes, and they are more polluted because they are pretty much open to the atmosphere. So once there are flooding and some rain and some other human activities, basically they are exposed to pollution. And so they are also usually it receives those water from industries, and these are untreated or treated effluents, and they also have more exposure to a lot of microorganisms just because they are open in surface. And if you compare river and lake, the lake will be calmer, so it means there's less turbulence, and probably there's a more chance of algal growth because of that situation. Probably there will be a more taste and odor problem and less turbidity, so it's clearer in lakes compared to river because of less turbulence. The water body will have sedimentation, and so suspended solids are actually going down to the bottom of the lake, and so water will be clearer. In comparison to river, river is always moving and exposed and a lot of turbulence, so there will be a number of disposal as well. This is discharge to the river, so it means that the river is a more turbid place and probably will have more pollution as well. So just to give a head-to-head comparison between groundwater and surface water, groundwater, because it is located underground, they have more constant composition. In comparison, the surface water is more variable, so it means it's changing. And in terms of mineral content, this more or higher mineral content for groundwater, especially on calcium or carbonates, because of the presence of rocks and so the dissolution of rocks in there. On the other hand, surface water has lower mineral content. Turbidity is also low, is quite clear in groundwater because, as you know, in groundwater there is soil, and soil usually acts like a filter. So when water seeps in through the ground, so it's like a filtration effect, and so the water that goes to the water table becomes more clear, so less turbid. On the other hand, surface water is, of course, it's exposed to the atmosphere and a lot of turbulence as well, so it's more turbid in this sense. The same way on the one that I mentioned in turbidity, the color also is quite low in color or quite clear in terms of the groundwater because of the filtration effect of the upper soil formation. On the surface water is exposed and it will have a lot of sediments, a lot of bacteria, and a lot of exposure to pollution, so it will be more colored compared to groundwater. DO level is quite low for groundwater because, as you know, groundwater is located underneath the ground. So the dissolution of oxygen is not that much because this is not exposed directly to the atmosphere. And so there's a low tendency of having DO concentration, low to no DO. This is very exposed to the atmosphere, and the pathway for dissolved oxygen is basically the dissolution of that oxygen content in atmosphere, and also the different the photosynthesis process in the plants, available plants in the surface water. So that's why DO is present and it's higher compared to groundwater. Hardness and these two here are also expected. If your rock formation and then the mineral content is high, your hardness will also be quite high. In comparison, surface water is not pretty much exposed to rocks all the time, but of course there will be some hardness as well because this is an open space. If you compare with groundwater, there's iron content, manganese content. Just because it is in underground and there are a lot of iron there, dissolution of iron will be rampant there. So all of these metals will be there. And this also, in surface water, there will be taste and odor due to some formation of hydrogen sulfide, for example, in lakes because of the depletion of dissolved oxygen at night, for example, in lakes, because of the way it works in the depletion of oxygen from plants formation or from plant use. And so H2S will be formed, and this one will make odor like a rotten egg. And while groundwater is also has some risk because we cannot observe it directly, we need to really pump the water out before we know if there's still available water there. But for surface water, at least there's a chance of looking at the surface water if water is still available or not. So in terms of knowing and having the um, the information of how much water is left, surface water is better because we can see it. But groundwater is better in terms of its quality and having a more constant composition. So if you compare groundwater and surface water, and if you go for water treatment processes, you will have also different processes for each one because of the different water quality and composition of that water. Of course, we know that seawater is basically high saline water. So the salinity of this seawater is around very high 3.5 weight percent. So that means that there are 35 grams of salt in a liter of solution. So almost 1 liter of water is inside. So around 965 grams are in water, pure water. So that's why when we do desalination, that 965 grams is a potential resource for pure water production. As we all know also that seawater comprises the biggest contribution in terms of water, our water volume on Earth. And so very, very high. So this is basically seawater here. And this part is the only fresh water, which is about the fresh water is very, very low, less than around 2% of fresh water. 30% of this 2.5% is groundwater. The rest are lakes and river, and the others are glaciers and snow. So you can differentiate how much volume we have. 97.5% of all water in the world is seawater or salt water. So there's a very big potential of this resource as a potential alternative potential source of fresh water. So in fresh water, I think I mentioned this one in our first lecture. It contains mainly of sodium and chloride, so it's NaCl. There's a number of various small amounts of magnesium, sulfate, and calcium, and some other metals and elements there. This is pretty much for potable use, would be practical if the communities are near the source, like the seas and oceans, because you don't have to really prepare a very long piping system, which could be very costly. And so much studies, especially reverse osmosis, is the state of the art of desalination, utilizing, of course, seawater as a source for providing potable water or other purposes as well. Stormwater is one type of source, a resource as well. This is basically the water quality is also different from seawater or from groundwater or from surface water. This refers to those water that originates from precipitation events. So it means from the rain, not directly from the rain, but the rain that goes towards the surfaces, for example, like rain that go to the roads or to the rooftop, to other surfaces that also once that collects the different sediments and some pollutants or contaminants along the way. And so like these leaves are there, there are a lot of sediments also that are carried away by the stormwater in the drain. So these are water that does not really soak into the ground, becomes surface runoff, and it goes directly to your sewer system or directly to waterways, for example, or is channeled into storm sewers. In this case, and eventually discharged to the surface water as well. So these are from precipitation events. So in stormwater pollutants, some of them are suspended solids, some oils and grease could be in the roads, coming from the roads, some salts even, some nutrients from irrigation, for example, metals from a company, a mining company, for example, it has to be a runoff there, and also a lot of bacteria that are available on the surfaces, and salinity, and so many others. So the quality of the water from stormwater also differs from places to places where it is located or being harvested. So some of these sources are construction site, gas stations will have a lot of oil there, gasoline. Parking lots is also a good source of the stormwater drains there, rooftops, golf courses, residential lawns. So as you can see, the different sources of this storm water will have different contents of various contaminants or pollutants also. And the most common one for wastewater is coming from domestic wastewater. So this is coming from household or some buildings that are, the contributors are our based on our personal activities like toilets, urinals, bathrooms, laundry, those coming from different buildings as well, some food buildings, for example. And so the composition will also vary, and this will be having more variation in terms of pathogens. The presence of pathogens is very high there here as well, because of the urinals and our toilet discharges. So the composition could be either as in the form of black water. This is basically water discharges from our human body in the toilet when you use the toilet. And gray water are those coming from baths, showers, laundries, kitchen. And so both of these will have also different water quality, but normally they have also some mix of wastewater for the overall water quality. So pretty much it's a predictable quality, in a way, because you will have some sort of idea already what are the things inside the domestic wastewater. They are not too different from each other, but it is different from industrial wastewater where different industry will have very specific things in their process, and so their water quality will be quite different. So some of the major characteristics of domestic wastewater will be these things. Basically, you can see BOD here, which is quite high. Coliform count is also high. Total dissolved solids is also high. Suspended solids is high. And depending on the amount of each of these parameter or characteristic here, you can you can differentiate them to be weak, medium, or strong. And so just refer to these example values, and you can see that the bacteria level is quite high already. So basically, wastewater will be quite full of microorganisms and microbes. So to end this one, basically, when you are given something as an engineer, for example, and you are given different water quality of for different sources of water. For example, A is a different source of water, B is a different source of water, and C and D and E are all different sources of water. And they have specific values for each of these different parameters like physical, chemical, biological. And so based on our discussion about each specific sources of water, you will have an idea where A, maybe you can assume where A is coming from, where C is coming from, based only from the water quality parameters. So take, for example, D. Probably this is the easiest one in all of these values given, because when you look at D, this has the highest value of 33,000 in terms of TDS. Say if you look at others, there are only 900, 600, 600, and 350. And this one is much higher, way higher compared to them. And so when we look at TDS, this refers to total dissolved solids. And when you say total dissolved solids, it's a combination of the salts and some minerals and other things there. So when we say 33,000, it means it could be possibly, there's no denying about this, it should be seawater, because it's a lot of salts in seawater. So let's see if this is really seawater. pH is also high, so seawater is quite alkaline. So probably it's gonna be a seawater, and there are not much lower in values in terms of coliform, which is called total coliform bacteria, is the total count of the bacteria. So this one is lower compared to others. This is quite high here, so it means that probably D is a seawater source. And if you look at another example, probably let's say this BOD. So BOD is refers to the pollution, high pollution. So if we look at here, the highest value is 275 in B. And so what source of water is a very polluted water? So you can think about, oh, maybe this could be a wastewater. This would be a raw sewage. And let's look at the number of bacteria, 10 to the 6. So it's pretty high amount of bacteria here as well. And there are other possibly indicator, chemical oxygen demand, which is pretty related to BOD, is also quite high. There's a lot of TDS as well. So from this example, I would say that B is actually a raw sewage. Okay, so you can work out the other examples A, C, and E, and you can see, and based from our discussion earlier, and try to assume and try to know what kind of water sources they are coming from.